Hello all, welcome to the series of operating system. In this video, we will focus on the priority based CPU scheduling or process scheduling algorithm. So this algorithm is famous because it focuses on the priority of the processes. Whatever processes are there according to the highest or lowest priority, it executes the processes. Okay, so that is why criteria is also priority, and the modes could be either preemptive or non-preemptive, but in this video we'll focus on the non-preemptive mode because the complete execution of the processes as per the burst time will be there through the non-preemption mode. So let us suppose we have the five processes with their arrival timings, burst timing, and here now our criteria is a priority. We are focusing on the priority. That means whatever highest higher number is there, so that means the higher priority. In this particular table, you can see what are the high priority values. So that is 2, 3, 4, 5, 5. So that means higher number means higher value. So higher number from this column is 5. That is higher, and lower is nothing but the 2. So that means 5 is having the highest priority and 2 is having lowest, and then sequentially 4, 3 are having the next priorities. Okay. Now here also we need to use the Gantt chart. Okay, and we have to check how many processes are arrived at the ready queue, right? And then accordingly we can calculate the completion timing, turnaround timing, and waiting timing. Okay, so this is the Gantt chart. So first of all, check how many processes are arrived at the ready state at the zero timing. Yes, only one process you can see. P1 process at the zero timing is arrived at the ready state. Okay, so initially we will execute P1 process. No matter what is the criteria, only one process is there at that time, so that is why we will execute the P1, because no other processes are there. You can see no other processes are there in the ready queue, so that is why directly we are executing process P1. Okay, so burst timing mode is a non-preemption. That means complete execution up to this unit will be there. Okay, so that means P1 process will be completely executed for 4 units, right? So that means P1 process is over, that is done. So but while executing P1 process, check any new process is there. Yes, P2 is received, right? At the first unit, second unit, P3 is also received, third unit, P4 is also received, and fourth unit, P3, P4, and P5. All remaining processes are received in the ready queue. Now we have four processes in the ready queue. Now in this case, check the criteria. Criteria is saying that highest number means highest priority. But see, the P4 process is also having the same priority, and P5 process is also having the same priority. If this is the case, in that scenario, we have to consider the arrival timings or the process ID, sequential process IDs. If still, for example, priorities are same and arrival timing is also same, so in that case we can focus on the sequential processes, right? Here P4 and P5 are having the same priorities, and sequentially you can see the arrival timing of process 4 is 3. So that is why we will execute process 4 for how many times? Burst timing is a 5, right? So 4 plus 5 is a 9. That means P4 process is a done. Now we have P2, P3 and P5. From P2, P3 and P5, which process is having highest priority? Last process is having highest priority, right? So we will execute P5 for how much timing? 2 units. So 9 plus 2, 11. Now we have only P2 and P3. You can see P2 and P3 are there. How which process is having highest in between P2 and P3? You can see 3 and 4. That means this is having the higher priority now. So P3 will be executed for 1 unit because burst timing is only 1. So 1 plus 11 is a 12. So P3 is also done. Only last process P2 is remaining. So that will be executed for 3 units. So that is why 12 plus 3 is a 15. Now see, we have calculated the completion timing when P1 is completed at the fourth unit. When P2 is completed, you can see at last 15th unit P2 is completed. When P3 is completed, here at this moment P2 is completed. That means at the 12th unit P2 is completed, P3 is completed, P4 is completed initially. You can see the at this stage P2 P4 is executed, and P5, when P5 is executed, 11th time. Okay, so now we have the exit time or completion time. Based on this we can calculate the turnaround time. So what is the formula for turnaround timing? Completion timing minus arrival timing. Completion timing is a 4, minus arrival timing is a 0. So 4 minus 0 is a 4. Completion timing is of 15 for the second process, arrival is 1. That means 15 plus 15 minus 1 is a 14. So 12 for the third process, completion timing is 12 minus 2, that is 10. So 6, 9 minus arrival timing is 3 for the fourth process, that is 6. Now last, for last process, completion timing is 11 and arrival timing is 4. So 11 minus 4, that is a 7. Now waiting timing is nothing but the turnaround timing minus burst timing, right? So turnaround timing is 4 minus burst timing, you can see 4. So 0. 4 minus 4, 0. 14 minus burst timing is 3, 11. Okay. So 10 minus 1 is the waiting timing, that is 9 for the process 3. 6 minus burst timing is a 5, so 1. And lastly, for fifth process, turnaround timing is a 7 minus burst timing is a 2, that is nothing but the 5. So now calculate the turnaround, average turnaround timing and waiting timing. 4 plus this 14, that is 18, plus 10, then 24, 28 plus 6. So that is something 34 plus 7. So near about 41. 41 divided by 5. 5 processes. So calculate the output in a unit and put your answer in the chat box. Similarly for waiting timing, 11, 0 plus 11 plus 9, 20 plus 1, 21 plus 6, 26 divided by 5, because we have 5 processes. So some unit will be your answer. Okay, so that is about the priority scheduling based on the non-preemption mode. Thank you.